Um, Good morning, guys. This is our last lesson in this unit. So we're just looking at how to fit exponential models to data. Let's start by trying to figure out what type of graph this is. If you look at this graph, where do you expect its asymptote to be? If we're going to look at this graph, we expect it to have a vertical asymptote because this is its vertical asymptote. It's going to get closer and closer. If I kept plotting, it gets closer and closer to its vertical asymptote. That's what the points are going to look like. And then on this side, it keeps on increasing, right? So it gets closer and closer to its vertical asymptote. Or another person can say that it curves away from its vertical asymptote because you can see it curving away from its vertical asymptote, right? Curving away from vertical asymptote. The other thing is it's concave, but it's concave downwards. It's kind of a ball, concave, which wouldn't be able to hold anything because everything is pouring out this way. So if a graph has this kind of shape, it could be concave this way, it could be concave that way, and it's going away from its vertical asymptote, then that kind of graph is a logarithmic graph. So two characteristics: it's curving away from its vertical asymptote, as you can see, curving away from vertical asymptote, and it's concave down, right? Concave down. So shapes like that are going to be logarithmic graphs. What about this one? Well, this one you can say it's curving away from its horizontal asymptote, because if you look closely, this line is its horizontal asymptote, and it's curving away from its horizontal asymptote. It's also concave, but if this was a ball, it would be able to hold something, so it's concave up. And a graph like this is always going to be an exponential function. So we've seen the characteristics are it's concave up, right? And it's curving away from its horizontal asymptote. So not that difference. This one is curving away from horizontal asymptote, and this one is curving away from vertical. Sorry, this one is curving away from its vertical asymptote, right? Vertical asymptote. What about this one? What do you think? So I can see lots of points, but generally I think you will have a shape like this, right? You'll have a shape like this generally, right? And if I look at that shape, I see that this shape is going to continue this way and gets closer and closer to the horizontal axis, but it doesn't touch it. So I can see that it's curving away from its horizontal asymptote. It's curving away from its horizontal asymptote. So I expect this graph to be exponential because remember, exponential curves away from horizontal asymptote, and it's also concave up. So it's an exponential function. What about this one? It starts by curving away from its horizontal asymptote. Nice and good. So it continues curving away, and then it approaches some maximum value, and it seems to be getting closer and closer to that maximum value, or actually it stops here at that maximum value. So I hope you remember this kind of model. This is what you call hope you remember it has some maximum value or limiting value or carrying capacity, and that model is what we call a logistic growth graph or logistic growth function. So we have an example here. Using your graphing calculator, try to create a scatter diagram of this data. So what you're going to do is go to your graphing calculator, go to start, right? Go to the start editor, right? Go to L1, and in L1, punch in all these values. 1, 2, 3, 4, 5, 6. 1, enter 2, enter 3, enter 4, enter 5, enter 6, enter. Then go to L2, and punch in all the values for f of x. 1, 1, 2, 5, enter, and so on until you punched all of them in. After punching in all of those values, go to your start plot. So push second function, right? And then push start plot. Start plot, I think, is above the top left button on your calculator, the button that says y equals. Above that button, if you push second function, it should say start plot. Make sure that scatter diagram is turned on, right? Make sure scatter diagram is turned on, and then if it's turned on, it's L1 and L2. Then you go to your graphing, and then you graph it. Graph it, make sure it's zoomed in properly such that you can see the window that it's graphed. After doing that, creating a scatter diagram which will look something like this. Go to, because the next part is we need to use a regression feature to find an exponential function that best fits the data in the table. So go to start, again push start, and then go to calc, right? When you go to calc, scroll all the way down. And when you look at this scatter plot, it should tell you what kind of function you expect. This function looks to be curving away from the horizontal asymptote. That's one. Second, it's concave up. If you poured water in this bowl, you would be able to hold the water if you kind of land it on the floor. So it's concave up. That tells you that you expect it to be an exponential function, right? So go to start, go to calc, scroll down until you find the type of regression that you're looking for. It's not a quadratic regression, it's not cubic, it's not whatever, it's not linear, it's not a natural logarithmic regression, it's not, oh wait, it's an exponential regression, oh wait, it's regression is that called? It's an exponential regression, yes. So you go to your calculator and then look for an exponential regression, because you expect your regression to be of the form y equals a times b to the power x. So yeah, it's an exponential regression. So push your calculator, punch exponential regression, and then it will give you the values on your screen. It will give you the value of a, it will give you the value of b, it will give you the value of r and r squared, but you're only interested in this value of a and in this value of b, right? You're not interested in a and b because the equation is supposed to be a times b to the power x, which is an exponential equation. Which is an exponential equation, so you have your a and b and you have your exponential function. When you're able to get this exponential function, try to write that equation into the, try to write that equation into the calculator and then graph it and see if the equation that you graph correctly fits these points, correctly graphs a curve that fits those points. Next part, they want me to write this as an exponential equation with base e. Now, if I want to introduce base e, I'm just going to look at this number. I know that if I introduce base e, then at the top I should have natural log of this number. I'm going to 4260, I write only 4 decimal places, times x. I'm doing this because I know that natural log and e cancel out to take me back to this thing. So if they want me to write it in terms of an exponential equation with base e, then I can just introduce natural log, and then my equation will look like this. So I'll have 776.6824 times e to the natural log 1.46 times x. So my answer is 776.6824 e. If you want, you can put the x in front of the natural log 1.426 so that you're not confused about what you're multiplying the x with. So it's the same thing if I do it like this. And if I write it like this, then my value of k, right, my value of k, because remember it looks like the equation a naught e to the power kt or kx, and if I write it in that form, then my value of k, this k is this whole thing, natural log of 1.426. So I can move from this kind of equation easily to that kind of equation. And the only trick I used here is because I know that e to the natural log is 1, that is the only trick I used to put the 1.426 up there. Alright, so I graph the exponential equation on a scatter diagram, and then after graphing it, I want to check, the next part is asking me, so yeah, you just type this equation in the plot. I'll show you in the next small video on how to use the calculator, and then you can plot the graph. Use the intersect feature to find the value of x for which f of x is 4000. That's an easy one. What you can do is on the y, on the plot, you can go and say y is equal to 4000, right? you just type equals 4000, then you can draw the line y is equal to 4000, and the point where that line intersects your curve is the value of x that you need or that you're looking for. So that's going to be the value of x that you want. Yeah, and the value of x I think is 4.6184 something something. Your calculator will tell you the things. This is your homework. I'm going to record another short video about how to use your calculator and then post it. Bye.